Okay, we are 1.2 today, and our big focus today is properties. And most, if not all of these properties, you should be pretty familiar with. Okay, as we look at these, you're going to see them, and you're going to be like, okay, I kind of remember this. And we talk about properties a lot, like in geometry, especially. When you first started solving equations back in Algebra 1, we talked about all the properties of equations, where if I add one number to this side, I have to add the same number to the other side, and so on. And so there is a lot of where we've seen these properties before, okay? Do we talk about this every single time? Like if I'm solving an equation, we don't always say, oh, I'm using the addition property of equality on this property, or on this equation. We usually don't identify the property, but the properties are what tells us that we can do what we do. Okay? Kind of like stopping at a stop sign when you're driving, right? There's all kinds of like things that you know you need to do. It's because the rules are out there, right? We know what the rules are, but we don't, every time we come to a stop sign, we don't say, oh, hey, this is a four-way stop, I need to do this. And you don't recite all the rules in your mind, you just know what to do, and you know because you do it every day. So properties would be kind of the same idea. Okay, so there are a bunch of properties, and I'm going to kind of, some of them are similar, bless you, and have the same property, but just a different operation that goes with it. Okay, so the first one, and here's what I'm going to do. I'm going to say the identity property, and some of these are for addition, and then some are for multiplication. It's still the identity property, but when I identify it, what we're going to do is we're going to say the identity property of addition, or the identity property of multiplication, because there's two of them. We don't just want to say the identity property, because which one is it? Okay, so if we think about what it means to be the identity, okay, like if I have my own identity, it kind of makes me who I am, right? And like for instance, I'm a math teacher, I'm a football coach, a lot of different things about me that make me who I am, right? And what I do. And the same thing goes for math. So numbers is kind of what we're talking about here, okay? If I have a number, what can we do to get back to that number that makes that number come back? So if I have addition, if I have a number like 7, what do I have to add to that number to get back to 7? 7 plus what gives me 7? 0. Yeah. So the identity property of addition says some number plus 0 equals that same number. And it works for any variable, no matter what, okay? I used 7 as an example, but I could put any number in for A, and that would be true, okay? It could be negative, it could be positive, it could be a fraction, it could be a decimal. Doesn't matter what the number is, okay? What do I have to do to get back to its identity, get back to itself? Okay, multiplication, same idea, okay, except we're multiplying. So what would I have to multiply by 7 to get back to 7? 1, yeah. So we're going to say 7 times 1 equals 7. And if we did it with the variable, a times 1 equals a. Okay. So you can do it with the number, but when we write the actual property, we always use a variable. Okay, and you can use whatever variable you want. Okay, that's the first one. The identity property of addition, the identity property of multiplication. One property, but it has two different parts. One's for addition, one's for multiplication. Okay, the next property. is the commutative property. Okay, commutative. If we kind of break down the word commute or commutative to commute, for instance, I live in Hutch, so I drive back and forth from Hutch to Bueller every day, right? I'm commuting back and forth to work. A lot of people in a big city will commute to work. That's where you kind of hear that word used a lot. When we do it with math, we're basically saying we're going back and forth, okay? And so in this case, M plus N equals N plus M. Order doesn't matter, okay? I can do it with numbers. 2 plus 3 equals 3 plus 2. When I add two numbers together, it doesn't matter what number comes first. I get 5 either way. Okay, multiplication would be the same. C times D equals D times C. 2 times 8 equals 8 times 2. And I'm just trying to show you an example with numbers. I can put any numbers I want to in there. It works for any of them. Okay. You might start to ask, like, okay, we got addition and multiplication. Why do we not have subtraction or division? Why are we only using these two operations? Well, think about subtraction. If I do 2 minus 3 and 3 minus 2, do I get the same answer? No. One's a positive one, one's a negative one. Okay? Multiplication, it works. Division, if I do 2 divided by 8 or 8 divided by 2, this gives me 4, this gives me 1/4. Okay? So it gives me two different solutions. So we don't really have properties for subtraction or division. Addition and multiplication, they work. Subtraction and division, they don't. Okay, the third one is the associative property. Once again, we got two of them. Here, what we're doing is we're changing what is associated or grouped together. Okay, to associate means it might be like your friend group. These are the people that I associate with or hang out with. Okay, kind of the same thing here. What are we putting together or what are we associating with one another? And when we do it with addition here for a property, we could look at it like this. A plus B plus C equals A plus B plus C. I know I'm kind of cramming that in there. Let me. Okay, so what happened here is I changed where the parentheses were, right? I changed what is associated with one another. But that doesn't change the answer. If I put some numbers in here, 2 plus 3 plus 4 equals 2 plus 3 plus 4. So we think back to like the order of operations, which is something we'll talk about later on. But as I look at this, over here on the left-hand side, I would do what's inside the parentheses first. So I do 2 plus 3, which is 5, and then I do 5 plus 4, which is 9. So the left-hand side gives me 9. Over here, we're going to do it in a little bit different order. 3 plus 4 is 7. 2 plus 7 is also 9, okay? So what we're saying here is what is being associated really doesn't matter. As long as it's the same three numbers, if I move the parentheses around, when I add those three numbers together, it doesn't really matter what comes first or second, okay, or third. So we call that the associative property. Same thing holds true for multiplication. R times S times T equals R times S times T. We're just changing where the parentheses are at, what is being associated with one another. If I put some numbers in here, if I go through and do the math here, 2 times 3 is 6, 6 times 4 is 24. Over here, I'm going to do the parentheses first. 3 times 4 is 12, 2 times 12 is also 24. So we did the math in a little bit different order. We did the multiplication in a little bit different order, but we still get to 24. Okay? So order does not matter, parentheses don't matter. Okay? And that's the difference between commutative and associative. Okay, commutative, the numbers flip-flop. Okay, here, the numbers are in the same order. We just change what parentheses and where the parentheses go. So that's really what you got to pay attention to when you look at those two. Another one that we have for both is the inverse property. Okay, the inverse property tells me I want to get back to the original number, okay, or what we call the identity, okay? So if I gave you a number like, let's say, 8, and I wanted to get back to the identity. 0 is what we call the identity, because that's the number we can add to any number and get back to itself. But what would I have to add to 8 to make 0? -8, yeah. Any number added to its opposite will always be 0. Okay? And so the rule here is, let's just do A. A plus the opposite of A equals 0. When you add two opposites together, 2 plus -2, or -9 plus +9. The order doesn't matter. It doesn't matter which one comes first or second, as long as we're adding the two opposites together. That's the key. For multiplication, it's a little tricky. If I set it up the same way, I'm gonna, so if I started with a number like 6, I think that's a little bit harder to come up with. In this case, we want to get back to the identity, which in this case is 1. So for addition, we want to get back to 0. For multiplication, we want to get back to 1. Okay, but this one's a little bit harder because we're trying to determine what do I got to multiply by 6 to get 1. And I think this one's kind of hard to come up with. And the way I think it would make more sense here, we are always going to multiply by its reciprocal. Well, 6 is thought of as 6 over 1. That's why it's a little bit harder to come up with like a whole number like 6, because it doesn't have a denominator to it. Not all numbers do. But if I flipped it, it would become 1 over 6. So if I did the rule here as like a property, we're always going to take a fraction and multiply it by its reciprocal. And that always gets us back to 1. Okay. So when we talk about the inverse, we always want to get back to the identity. What do we have to multiply or add to get back to that identity? And you don't have to change the sign or anything like that. If this is positive, this is positive. If this happened to be negative, then this would also have to be negative as well. Okay, so there's no flipping of the signs or anything like that. Just keep the sign the same. Okay, this one does not have two properties. This is the multiplication property of 0. And the name pretty much tells you everything you need to know. Okay, we are multiplying something times 0. If I took 6 times 0, what would I get? 0. So any number times 0 equals 0. It doesn't matter what that number is. Positive, negative, fraction, decimal. I could take 1,000,000 times 0 and I would still get 0. Okay? Every number times 0 equals 0. Okay, and then the last one, these two are just kind of standalone properties. This is one you probably are the most familiar with, or at least have heard. Because even going back to like Algebra 1 and Algebra 2 a lot, we use the distributive property all the time. And where we use the distributive property is when we have parentheses. We're taking whatever the value is in front of the parentheses and we're distributing it to whatever's on the inside. 8 times b plus 8 times c. So I'm going to give you a couple of different examples. When we see distributive property, we typically think one thing. We're combining like terms or solving an equation, whatever. I'm going to show you, first of all, with all numbers and kind of show you why the parentheses and the distributive property works. Okay, so two different ways of evaluating this problem. If I look at the left-hand side, on the inside of the parentheses, we would do 3 plus 4, right? 3 plus 4 is 7. 7 times 2 is 14, okay? Because all we have is numbers in here, I can actually evaluate that problem and I can get a value, 14. Over here, 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is 14. So we arrive at the answer two different ways, but we still get the same result. 14 would be our result, okay? And we can only do that if we have all numbers in there. Okay. And maybe you've never seen the distributive property done like that, because when we first talk about the distributive property, we don't necessarily talk about it with all numbers, probably. Or if you did, you may not even remember doing it like that. Probably the way that you're most familiar with seeing the distributive property is something like this, with a variable included in it. And if I wanted to rewrite this expression, we're going to take 3 times x, and we're going to take 3 times 2. And there's not really any simplifying to be done there. I mean, we have simplified this to be this, but we can't actually evaluate it because right now we don't know the value of x. Okay, so it won't always be all numbers like this one was. I just want to show you a couple different ways of the way you can think about distributive property. This is probably the way that we remember the distributive property the most. And we've used the distributive property to solve equations before and do some different things as we solve and simplify things. Okay, that's all of our properties. One last thing I want to do here, because you're going to do some evaluation of numbers today, and you're going to apply properties and things like that. One thing that I want to mention here before I let you go and maybe work on our assignment a little bit today. If I divide by a fraction, okay, and I'm not really going to limit your calculator use, right? But I also think it's helpful to understand why and how something comes up, okay? And here's kind of the main reason why. If, I'll use an example that's kind of easier to understand. Let's say I have a pizza that has 8 slices in it, right? And I got a bunch of people coming over and I'm going to share my pizza. And everybody shows up and I got like 12 people that show up. I don't have enough pizza for everybody, right? So I decide I'm going to take all of my slices of pizza and I'm going to cut them in half. So I'm going to take my 8 slices and I'm going to divide those 8 slices in half. How many slices do I have? Now I got less. I got 12 people I got to feed, and now I only have four pieces. Okay, think about this. If I take those 8 slices, okay, let's draw a picture here. There's my 8 slices, right? I'm going to take those 8 slices, not going to be very big, but I'm going to try to get more slices out so everybody can have their own slice. I'm going to slice here, slice here, slice here, slice here. So now we got 16 slices, right? So if I were to take those 8 slices and divide by half, now I have twice as many, right? I have more, okay? So I started with 8, I cut those 8 in half, I divided by half, okay? And so now I have twice as many. So the rule here is when I divide by a fraction, we're going to multiply by its reciprocal. And so that would give me my 16. Okay. The rule here that we use is keep, change, flip. You guys remember that one? Maybe been a while since you've heard that. Okay, here's what keep, change, flip means. Anytime you divide by a fraction, you can always use keep, change, flip. Okay, we're not really solving an equation. We're just multiplying or dividing by a fraction. We're going to keep the first fraction the same, 1/3. We're going to change the sign from division into multiplication. And we're going to flip the second fraction. Keep, change, flip. And when I multiply 2 fractions together, all we have to do is multiply straight across. There's no common denominator needed or anything like that. 1 times 5 is 5. 3 times 2 is 6. 5 over 6 would be our answer. Okay. And I think that's helpful to know and understand. I know that you could probably just type that into your calculator, and your calculator is going to punch out 5, 6. Okay? But we kind of have to understand why. And I show you this reason because if we take 8 divided by 2, 8 divided by half, then typically we would think 4, right? Because we think, oh, half of 8 is 4. But we're not multiplying by a half, we are dividing by half. And so those 2 operations change how we approach it and change how we think. Okay? Any questions on that? Kind of makes sense? You guys kind of remember that? Keep, change, flip? Okay, sign for today. Okay, so this is going to be a little bit different for you. Here's what this means. 10 to 98, that sounds like a lot of problems, right? 88 problems. You want to do 88 problems tonight? Yeah, you do? All right. Then we won't do the by 4. We'll just do 10 to 98. I'll ask somebody else tomorrow, so I don't throw Kalia under the bus. Okay, we'll start with 10, right? 10's our first problem, and then we're going to go by 4. So that means we just add 4. You mean I got to add when I'm doing my homework assignment, and I got to add 4 to 10? Man, that's rough. All right, so we'll go 10, 14, 18, and if I counted right, then we should end up on 98. Okay. So it's a lot better than evens and odds, because there's half as many. If we did even and odds, there would be twice as many. So some days we'll go by, because there's so many problems in this section, or in these sections, then there's a lot of stuff going on. Okay. I could give you an example like this. You're going to have some problems where it's going to ask you, what property are we talking about here? What property is being displayed here? So the question you really want to ask yourself is, what's happening? What's different? What's changed, right? So over here, we have 2, 3, and 4. Here, the 2 and 3 have traded places, okay? And so when two things trade places, then what property do I have? Property says that two things can trade places and still be the same. Look down at your properties that we just talked about. Which one does it look more like? Commutative. Yep, because the 2 and the 3. Now, I gave you this one on purpose because it has parentheses, right? So when people see the parentheses here, they think, oh, yep, here's associative because it has parentheses in it. Not necessarily, okay? You have to pay attention to what's happening, and because they just trade places, nothing happened to the 4. It didn't trade with anything, right? We didn't trade the parentheses and change where the parentheses are at. All we did was trade where the 2 and the 3 were. And so we would say that this is the commutative property of addition. And in order to determine which property it is, what sign is between the two numbers that flip-flopped, okay? The 2 and the 3 flip-flopped. So they have an addition sign in between. Okay? That's one that's a little bit tricky to kind of identify, mainly because we see parentheses and our mind immediately thinks, oh, it's parentheses, so it's got to be associative, but not necessarily. Okay? Is if we looked at it like this. If I had a fraction, okay, what could I multiply by a fraction to make 1? Any ideas? Okay, so if I did 1 over 1, what would 1 over 1 really be? 1. So if I multiplied by 1, what would happen? Stay the same. Yep. So really what we want is we want this whole thing to disappear and then be left with 1. Okay? So if I have a 6 on bottom, what would make a 6 disappear? Where would another 6 have to be? What would make the 6s disappear?
On the bottom?
Close. If I have one number on bottom, I need a number on top to make it disappear, right? So in order to make the 6 disappear, I would need a 6 on top, right? Because 1's on bottom, 1's on top, those 2 would disappear. Okay, if I have a 5 on top, what would I want on bottom? 5, yeah. Okay, because what would happen if I multiplied these two together? 5 times 6 is 30. 6 times 5 is 30. 30 over 30 is 1. Okay, So what is the word for that? Yeah, reciprocal. Good. Okay. This is the reciprocal. So when we talk about the multiplicative identity, that's kind of a big word. It's kind of a tongue twister, multiplicative.